In a prior lesson, we've taken a look at the standard deviation and how it's interpreted. I've also taken a closer look at Chebyshev's theorem and how it works. In this video, we're going to take a deeper dive into the empirical rule. Are you ready? Let's go.
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Hi, Mark here from 6 Minute Statistics. Before I begin, let me come clean about something. I think we've all been thinking it. When I decided to make short videos for statistics, I came up with the name 6 Minute Statistics, and it was catchy. It was perfect. However, some of you guys have noticed that I've managed to keep these videos to just under 7 minutes. And I got to tell you, it's taken a lot of creative editing to get under 7 minutes. So while I'm still going to call the channel 6 Minute Statistics, just know that I know that you know it really should be called 6-ish Minute Statistics. Wow, I feel better. All right, on to today's topic. The empirical rule is the second rule we look at when working with standard deviation. It provides better, and I'm going to read that as more accurate information than Chebyshev's theorem, but it is risky. It only works for mound-shaped symmetric data. If you have that beautiful bell-shaped curve, the empirical rule in this video is for you. If not, however, I'm going to refer you to Chebyshev's theorem. I'll provide a link at the end of the video. Here's how the empirical rule works. We're going to begin with a curve of the data. We draw that mound-shaped symmetric curve and draw in a value of the mean in the center of the curve. Next, we're going to add and subtract 1, 2, and 3 standard deviation lines from the mean. Notice I'm spacing the standard deviation lines so that that third standard deviation line falls pretty far, almost all the way out in the tail of the distribution. You're going to see why in a second. Here's what the empirical rule says. It says approximately 68% of the data fall within 1 standard deviation of the mean. Approximately 95% of the data fall within 2, and then approximately 99.74, I don't know why anybody would use those numbers, but some people do. I'm just going to say approximately 100% of the data fall within 3 standard deviations of the mean. In the standard deviation video, I took this information and we made the following standard deviation interpretation. We expect most of the data to fall within 2 standard deviations of the mean. Been there, done that, you say. We've seen this before. Fair enough. So let's dive deeper. Let me use an example to explain. Let's check back in on my favorite artist. In an earlier video, I sampled a bunch of the paintings she's created over the years, and we found that the average time to complete the paintings was 20 hours. Suppose I also tell you that the standard deviation of the times to complete the paintings was 4 hours, and that the shape of the time distribution was approximately mound-shaped and symmetric. Suppose I want to find the percentage of her paintings that take more than 28 hours to complete. All right, let's take a look back at that curve we drew earlier and substitute the painting times, the mean and the standard deviation values, for the 1, 2, and 3 standard deviation lines in the picture. Notice in this case that the value of 28 hours that I'm interested in falls 2 standard deviations above the mean. Our good friend the empirical rule tells us that approximately 95% of the times fall within 2 standard deviations of the mean, or in this case, between the values 12 and 28 hours. So what percentage falls above 28 hours? Well, if approximately 95% of the times fall inside, that means approximately 5% fall outside that range. Unlike when we were using Chebyshev's theorem, we can split that 5% in half. Why? Because we have a symmetric curve. We better have a symmetric curve. We're using the empirical rule. So we can take that approximately 5% and split it into 2 separate approximately 2.5%. And that's how we're going to answer the question. We're going to say approximately 2.5% of the paintings take more than 28 hours to complete. By the way, that would be the same percentage for the proportion or percentage of paintings that take less than 12 hours to complete. Just like Chebyshev's theorem, the empirical rule can be used to give us the percentage inside each of those 1, 2, and 3 standard deviation ranges and outside. But that's not all. Because of the symmetric property of the empirical rule, it's more flexible. Let's take a look at this problem. We want to find the percentage of the paintings that take between 8 and 24 hours to complete. We won't be able to solve this problem using Chebyshev because the 8 and the 24 fall on different standard deviation lines. In the empirical rule, we're going to have to take a look at two of the statements in order to solve this problem. Let's begin with the 8 hours. Notice that it falls 3 standard deviations below the mean. Well, the empirical rule tells us that approximately 100% of the painting times fall between 3 standard deviations of the mean, in this case between 8 and 32 hours. If approximately 100% fall between 8 and 32, we can split that number in half and talk about the percentage that fall between 8 and 20 hours. So we're going to say approximately 50% fall in that range. Now, how about the 24? Well, the 24 falls 1 standard deviation above the mean. And again, our friend the empirical rule tells us that approximately 68% fall within 1 standard deviation of the mean, between 16 and 24. But I don't want 16 to 24. I want 20 to 24, so we split it in half again. We take that 68% and we end up saying approximately 34% fall between 20 and 24, and then we put the results together. We take the 50% between 8 and 20, we take the 34% between 20 and 24, and we conclude that approximately 84% of the paintings take between 8 and 24 hours to complete. Now, I did that with 3 standard deviations below the mean and 1 standard deviation above the mean. You can do that with any of the values in the lines. You can use 1 above, 3 below, 2 above. It doesn't matter. And that's your next step. Your next step is to practice. Take a look at different empirical rule problems, play around with different standard deviation lines, and make sure you're really good at it. After you complete that, make sure you're also really good at Chebyshev's theorem. Check out the video I've created to help you. And I think that's it. That's your deeper dive into the empirical rule. Now, subscribe to my channel. It's time to get to work.